Hello everyone, good afternoon. So I am going to today I am going to uh, explain the experiment number 3 of the introduction to electronics laboratory, and the aim of the experiment is to draw the voltage rectifier circuits using the PN junction diode, and that will be a half wave rectifier, center tap full wave rectifier, and full wave bridge rectifier without filter and with capacitive filter. And then to analyze the operation of a half wave rectifier and a full wave rectifier using the input voltage of frequency 50 Hz, and to determine the peak output voltage, the average value of the output voltage, peak inverse voltage, that is PIV, and ripple factor and rectification efficiency, RMS voltage, peak load current, and frequency of the rectified waveform. So these are the components we have used. The AC source of 50 Hz and 120 volt, transformer, diodes that will be of 1 and 4148, it will be of 4 quantities, and resistor of 1000 kilowatt, resistor of 100 kilowatt, resistor of 10 kilowatt, and capacitor of 1 mu f farad, and wire of copper that will be as required we will use. And coming to the theory of the experiment, so the basic DC power supply. So a DC power supply of standard 120 voltage and 60 Hz AC available at wall outlet into a constant DC voltage. So if it will be a AC voltage, then if it will be an input, then when it will be passed through the half wave rectifier, we'll get this type of half wave output voltage, and when we pass through the full wave rectifier, we'll get this type of output voltage. So using the filter and regulator, we can also make it a DC type. Like if we will use filter, then it will be like these ripples will form, and when using the regulator, it will be complete straight line, that will be DC voltage. So these are this is the circuit diagram, and the sources, the output, this is the input source, and this is the output voltage for the half wave rectifier. So these are the theory in which we have explained the half wave rectifier, and the average value of the half wave rectified output voltage, the peak inverse voltage, and these are the circuit diagrams, and the model diagram for the full wave rectifier, and this is the input voltage, and this is the output voltage, and this is for center tapped rectifier. This is the circuit for center tapped rectifier. So coming to the theory, the full wave rectifier, in which we have explained the what is full wave rectification. There is a DC level obtained from a sinusoidal input can be improved 100%. That will get all the will process all the waves, like unlike the uh, only one directional wave will not be taken into account. And after that, we'll come to the center tapped full wave rectifier, in which the VPRI equal to V in, and the diode D1 will be in forward direction, and diode D2 will be in reverse direction with PIV across it, and we'll get the PIV values from that also. And we'll get to the full wave bridge rectifier. The full wave bridge rectifier have 4 diodes we will use. This is the rectifier for this is the center tapped effect rectifier, in which D1 is in FB and D2 is in RB, and this is also the center tapped rectifier, in which D1 is in RB and D2 in FB, and this is the input, and this is the output we get. Here you will use 2 diodes and a resistor, and this is the bridge, the full wave bridge rectifier. This is the input voltage, this is the output voltage we will get, And in this, for positive half cycle, the D1 and D2 are forward biased, D1 and D2, and D3 and D4 will be in reverse biased. So basically D4 and D3 are will be open circuited, and this D1 and D2 will be in short circuited. After that, coming to the theory, peak inverse voltage. What is peak inverse voltage and how we will calculate for full wave bridge rectifier? And for half wave rectifier with a capacitor input filter, we will have ripple voltage and ripple factor. These are the terms we will come across it across this experiment. And this is the circuit diagram for the negative half cycle of the full wave bridge rectifier, in which D3 and D4 will be in forward biased and D1 and D2 will be in reverse biased. So D1 and D2 will be open circuited and D3 and D4 will be short circuited, and this will be the path for the current. This is the diagram for the ripple voltage, and these are the ripples formed while we use the capacitor across the load. We'll get these ripples which will improve the DC source to a straight line. After that, we have full wave rectifier with capacitor filter. Here also, like half wave rectifier, we'll also use the full capacitor filter in full wave rectifier, and respectively we'll get the DC source. And coming to the experiment procedure, that is without filter. So we'll select various components of specific ratings we have shown in the component table, and these are the circuit diagram for the full wave bridge rectifier, and this is for ripple voltage. And again the procedure, so join the voltage source with the primary side inductor and also connect to a ground. And after that, we'll for half wave rectifier, connect a diode resistor with a secondary side inductor and mark an output terminal for resistor. For center type rectifier, connect to two diodes, and then for output terminal, attach a resistor and a ground as shown in the circuit diagram. And for full wave bridge rectifier, we'll connect four diodes according to the diagram, and then connect a resistor with opposite ends of the bridge circuit. Now I'll go to the simulation edit, and click the transient, and select the stop time as 100 ms, that is millisecond. And we'll run the circuits and observe various plots and note down the parameters. With filters, we'll follow all those steps, all those above steps, but only in step 3 we'll connect the capacitor in parallel to the load. These are the observation and conclusions we have got. So these are the values of the 13.803, 13.800, and 13.147 are the values of peak output voltage uh, for the half wave rectifier, center type rectifier, and full wave bridge rectifier respectively. So coming to the calculation part, we have found out this peak output voltages and V average from the peak output voltage, that is PV out divided by pi, 2 PV out divided by pi, and 2 PV out divided by pi. So, and peak inverse voltage, that is PIV value, we have calculated, and ripple factor, that is the formula for V RMS divided by VDC whole square minus 1 the whole root. So for half wave rectifier and for full wave rectifier, we have got the values 1.21 and 0.43 respectively. So observation and conclusion, from the transient, we have observed that half wave rectifier provides the rectifier for half period, while the full wave rectifier will provide for full period. So output frequency is double for full wave rectifier, and the rectification efficiency, the full wave rectifier is much better than the half wave rectifier. Using the capacitor as a filter, we'll notice that ripple voltage is higher for half wave rectifier than full wave rectifier. Coming to the application of the experiment, so half wave rectifiers are used in powering appliances in AM radio, in soldering iron type of circuit. Full wave bridge circuit rectifier are used to detect the amplitude of the modulating radio signals. These center type rectifier are used to convert between high AC to low DC. So these are the calculations we have done for rectification efficiency and RMS voltage, which can be found out from the PV out, PP out. These are the short questions and answers. What is the advantages and disadvantages of each of the rectifier circuits? So these are the advantages of full wave rectifier, disadvantages of full wave rectifier, then disadvantages of bridge rectifier, the advantages of bridge rectifier. Likewise, we will get the different advantages and disadvantages of the rectifiers we have done in this experiment. Then explain the operation of a capacitor input filter. So these are the formulas. These are the formulas we have used. So in the experiment to find out the peak inverse voltage, average voltage, and peak in current across the load. Likewise, and the questions: determine the PIV for diode in a filter rectifier. Define ripple voltage and discuss its cause. Derive the expression for ripple factor. Again, these are the formulas we have used in this experiment for the calculation. Then the question: at what point the input cycle of a positive half wave rectifier does the PIV occurs? For a half wave rectifier, there is a current through the load for approximately what percentage of the input cycle? And what is the average value of full wave rectifier voltage with a peak value of 60? So we will get the formula 2Vm divided by pi, and we will get the V average as 88.197 voltage. Which type of full wave rectifier has greater output voltage for the same input voltage and transformer turns ratio? It will be bridge rectifier. For a given output voltage, so the PIV of bridge rectifier diode is less than the center rectifier center tapped rectifier diodes. True or false? So this will be true. So these are the simulation results and the circuits we have drawn for different circuits with and without filters. These are the 6 circuits we have drawn and the simulation results given here. So thank you.